We are going to go over METARs and TAFs, how to read them, how you can practice reading them so that you can get ready for the FAA Part 107 test. If you haven't downloaded my FAA Part 107 exam study guide, you can go to offers.flyelectricmonarch.com/study guide. That has got all of the different free resources that are published on the web for you to prepare for your Part 107 study guide. If you have purchased my Part 107 course, or if you are a member of the Drone Pilot Academy, you do have access to my detailed instructional lessons on how to read and interpret METARs and TAFs and other weather reports. In this video, we're specifically going to go over METARs and a little bit in TAFs today because the decoding of METARs and TAFs are very similar. Once you understand how to decode a METAR, you just translate a little bit more for a TAF for a forecast. So the first thing I want to share with you here is the Pilot's Handbook of Aeronautical Knowledge. This is a very thick book. You can purchase it on Amazon if you would like. Flight schools sell them at your airport too. You can download for free the PDF chapters of the Pilot's Handbook of Aeronautical Knowledge. If you're like me when you're studying things and you like to write and take notes, I do suggest just purchasing the book. You don't need to know everything in that book for the remote pilot exam. In my study guide, I show you exactly what chapters you need to study to prepare for the exam. So in chapter 13 is on weather in the Pilot's Handbook of Aeronautical Knowledge. It's on aviation weather services. So this chapter does go into detail on a lot of the different aviation weather services that are available out there. Not all of these are relevant to you as a remote pilot. For your Part 107 exam, you do need to know how to decode a METAR and some of the different nuances of things that come with a METAR. So you can read through this section of the Pilot's Handbook of Aeronautical Knowledge. It's going to give you all the detail on the METARs. These are called aviation routine weather reports. METAR does stand for meteorological aerodrome. There's a lot of French words in aviation. We just go with it. Okay. So that's where the term METAR comes from, but it is a routine weather report. It is a surface weather report on what's happening at that particular station. They're normally at an airport. Okay. There's some that have weather stations outside of the airport itself. But generally speaking, METARs are going to be located on an airport. You have automated systems. You can have systems that a human has to intervene. You can have different systems where the human is actually putting out the METAR. But generally speaking, these are automated weather reports that come out once per hour each day for the surface level weather observation at that particular airport. Okay. You might see this right here, this SPECI. So like right here, it says METAR. You might see that SPECI in parentheses. That is a special issuance of the METAR that is outside of that routine report. So like this one, for example, you'll see a lot of them are recorded at 53 after the hour. So this one is released at 17:53 Zulu. So if one needed to come out at 18:04 Zulu, you would see the speci after that. And so the reason that you might get new METAR reports outside of those automated reports, the automated routine reports, things like weather conditions can change. They can go from VFR to moderate VFR to IFR. There might be a correction. You would see this. You would see a COR, which you would see right here. You'd see that COR. Generally speaking, you're going to see those special METAR reports when the weather goes from VFR to IFR or IFR to VFR. All right. So that's mainly when you can see. There's other instances that you're going to see that, but generally speaking, that's what you're going to see. So in the Pilot's Handbook of Aeronautical Knowledge, they give you this example here of a METAR. Okay. And when you go take the Part 107 exam, they're going to give you a METAR and they're going to ask you a question about it. And you're going to get answer A, B, C, D, whatever it might be. And you have to choose which is the right answer. So in some of my other webinars, some of my other trainings, you've heard me talk about test taking strategies. And if you don't know the answer, sometimes the best way to go through it is to figure out why the other answers aren't correct. Okay. And so if you know how to decode these METARs, sometimes you can figure out if you see some weird, obscure code, you can use that sort of process of elimination to figure out what it might be. Like, for example, this one right here, this BR, it confuses a lot of people. BR means missed, French term. So, like I said, a lot of French in aviation, but that BR does confuse a lot of people. So I think if you go down further down here, it does give you some of the descriptors, some of the terms that you see right here. BR is mist, FU is smoke, fumar, dust, sand, haze. It's going to tell you the reason why there's different low visibility. Okay. So you'll want to know what some of those are. This particular example here, this is a METAR for the airport is KGGG. It was released on the 16th day of the month at 17:53 Zulu. It is an automated system. The wind, you can always remember wind directions is in 360 degrees. So you're going to have three numbers. The wind is coming from direction 140. It's at 21 knots, gusting to 26 knots. Visibility is 3/4 statute miles. There's heavy thunder showers and rain. The plus sign means heavy. You could see a minus sign there as well. And there could be nothing there as well. So TSRE is just going to be thunder showers and rain. BR is going to be mist. This is where you're going to start seeing cloud information. This is important. This is all important for you as a remote pilot, but this is what's really going to help you determine visibility and cloud clearance is really going to help you determine is this VFR, moderate VFR, or IFR weather. Broken at 800 feet is our cloud ceiling. So broken and overcast are our ceilings. Overcast is 1,200 feet. CB means cumulonimbus clouds, which does make sense because cumulonimbus clouds generally go with a thunderstorm. Okay. Temperature is 18. Dew point is 17. So that's going to be in centigrade or Celsius. When that temperature and dew point is very close together, you're going to get fog. Okay. So that temperature dew point spread is real close together. That would concern me as well as a remote pilot, as any kind of pilot, really. Altimeter setting is 2970. That is the setting that a manned aircraft pilot or a crewed aircraft pilot is going to set in the altimeter to make sure that their altimeter is reading the correct altitude. And then remarks, RMK is remarks. PRESFR means pressure falling rapidly. So this barometric pressure here, this altimeter setting here, the pressure is falling rapidly. So this METAR really just indicates all over the board that there is a storm. Okay. So that's what is happening right now at 17:53 Zulu at the KGGG airport. So now let's just say everything cleared up. The clouds cleared through. There's no more rain, no more mist, nothing. If that just happened between 17:53 and 18:53 Zulu, that's when they'll issue a special METAR. Okay. But generally speaking, you're going to see those once an hour at airports that have METAR reporting capabilities. Okay. Now, in the Pilot's Handbook of Aeronautical Knowledge, this has got different descriptions of what I just read to you. So I went through and decoded this METAR for you. You can use this. Number one is type of report, and they really should number that so you can know number one is this type of report. All right. Station identifiers, number two, right here. Okay. Date and time of report is number three down here. Okay. Number four is the modifier. So that's going to have any sort of information about it's automated. Then we have wind. Okay. Wind is reported with 5 digits. Like in this particular example, 140 at 21 knots. But this one, we're showing wind gusts. So that's why you see the gust to 26 knots. If the wind direction is below 100, so the wind is coming from 090, it will say 090. So it's always 3 digits for the wind, 3 digits in the direction, one, generally 2 for the wind speed. If wind speed gets up over 100 knots, you've got other issues happening there. Wind gusts are again identified by the G. Visibility right here. This is the prevailing visibility. It is always reported in statute miles. This is for the US. ICAO is that overarching governing body worldwide for aviation. And so METARs are use the same format worldwide, but there's going to be some differences between countries. For example, in the US, we do report visibility in statute miles. Okay. But we do report temperature and dew point in Celsius. Runway visual range is something that you might see for the visibility. Right here, it would say something like RVR for runway 17 left is 1,400 feet. If the visibility is super low, some airports do have that capability to report runway visibility or runway visual range. So if you're standing at the end of the runway, how far down the runway can you see? That's what that means. So the RVR for this in this particular example would be 1,400 feet. So you could see that here for visibility. So if you've got the four statute miles or 5 statute miles or whatever it is, that's the statute miles. If you see RVR, they're reporting runway visual range. And generally, you're going to see that when the visibility is super low. It's just how far down can you see the runway. Then we get into the different weather phenomena that's happening in this particular example. Again, we've got heavy thunder showers, rain, mist. Again, you may see a minus, you may see a plus, you might not see anything there at all. Okay. If you do see the VC right here, VC, and you might see this with when they're reporting any sort of lightning, thunder showers, that kind of thing, it will state VC if it's in the vicinity of the airport. So it wasn't reported directly on the airport or directly over the station. It is in a 5 to 10 mile radius of that particular airport. So that's also important to note that there might not be lightning happening right there, but that it could be happening close by. All right. Next, we have the sky conditions. So right here, we have the sky conditions. This is going to be your cloud reporting. So it's either going to be clear. You're going to have right here. This chart right here is important to note. All right. Broken and overcast are your ceilings. All right. This means that 5/8, so from 5/8 to 7/8 of the cloud, of the sky being covered with clouds, that's a broken ceiling. And then 8/8 or it's completely overcast. It's already, the whole thing is filled with clouds. Those are going to be ceilings. You cannot go above those. All right. A few and scattered are part of your cloud conditions. All right. So if 1/8 to 2/8 of the sky is filled with clouds, you're going to see few. 3/8 to 4/8. So about half or less of the sky filled with clouds, you're going to see scattered. This is where you're going to have poofs of clouds in the sky, but you can still see through. There's, clear sky, blue sky, visible beyond those clouds. Okay. So it's going to report where those clouds are from an altitude standpoint, but then also what is the sky cover? What is the amount of clouds that you're going to see in the sky? Anything less than 1/8, they're going to report it as. You're going to see this in a couple of different ways, depending on the METAR. You might see SKC for sky clear. You might see CLR or few. So you could see, if you're at the 1/8, you might see few there as well. So that is going to be your sky conditions. On METARs, the sky conditions or the cloud levels are going to be reported in AGL or above ground level. So this is the reason for that is because when a crewed aircraft pilot is looking at a METAR, when they're looking at a task, they're generally looking at that while they're doing pre-flight planning prior to getting on the airplane, the helicopter, the whatever they're flying. Okay. So while you're looking at something on the ground, things are generally going to be reported in AGL. Whereas if the pilot is looking at something while they are in an airplane, they're looking at the altimeter. The altimeter is reporting MSL. So anything that they're looking at in the aircraft itself is going to be reported in MSL. So that's an easy way to remember. How do I know if they're reporting AGL or MSL? Looking at weather reports that you're going to view on the ground versus an aeronautical chart that a pilot might be using in an aircraft, they're going to report things in MSL. All right. So on METARs, your clouds are going to be reported in hundreds of feet AGL. Anything above 12,000 feet are not going to be reported by the METAR. You might see cumulonimbus or TCU, which is towering cumulus, which are going to be those very high clouds. Those can be reported with their height. You saw in the example here, they did not report the height of those cumulonimbus. So what this means is there's an overcast layer of clouds at 1,200 feet AGL, cumulonimbus clouds. So how high up do they go? Do they go up to 60,000 feet? Oftentimes, if you have a cloud layer at 1,200 feet, it might only go up to 1,400 feet. Okay. You don't know. But in this particular case, we've got cumulonimbus clouds. So it's probably going to be a pretty high cloud. All right. Then up here, we've got temperature and dew point reported in 18 and 17 were reported in Celsius. And then anything that is reported below 0 degrees centigrade or Celsius has an M in front of it to indicate it's a negative temperature. The altimeter setting is reported in inches of mercury. On this particular example up here, the altimeter setting was 2970. That is reported in inches of mercury with that decimal point. It would be 29.70 inches of mercury. A manned aircraft pilot, when they are in the aircraft, they're going to dial that in to their altimeter so that they're getting the correct altitude readings while they're in the sky. And again, we saw pressure falling rapidly. You can also have pressure rising rapidly. See, it's just the opposite of pressure falling rapidly. You got pressure rising rapidly. Zulu is all times are reported in Zulu. And so what you can do is you can find online, you can find Zulu time converters, figure out where you are, plus or minus. It's Greenwich Mean Time. So it's the zero meridian that goes to Greenwich, England. This particular example here is 1753 Zulu. I don't know where KGGG airport is, but if you're 7 hours minus, that would be 1053 local time. So you can go and you find those Zulu time converters to figure out where your airport is that you're looking at. Where are they? And then how many hours behind that Greenwich Mean Time now are they? But Zulu is the term that is used in aviation for the universal time zone. And then you'll have a remarks section. You're going to see lots of different things there. Some things you might have to look up. Like this one right here, you might see occasional lightning. You might see things like cloud to cloud lightning or cloud to ground lightning, some really weird, obscure things. And you might have to look those up because you just don't see those very often. This is one I don't see very often, but that's what that means is you've got cloud to cloud or cloud to ground lightning. So there is a couple of different codes here for you. If you've got the Part 107 course, I've got that in there for you as well, that some of the different codes that you're going to see and what they mean. And really, honestly, this is just like, you see these over and over again that you just know what they are. Okay. And some of the ones that I think are really obscure. I don't live near volcanoes, so I'm not going to see volcanic ash here very often. But if I live near a volcano, you might see that quite frequently. FC funnel cloud. I used to live in Wisconsin, saw that quite frequently. Don't see that as much out here in Arizona. You get used to seeing what these are. So now to prepare for the Part 107 exam and to just drill yourself on how to read and interpret METARs, I've got a couple websites that I want to give you here. So 1-800-WX-BRIEF is a website that is official aviation weather. You can go to, you can pull up weather, METARs, TAFs, and then you can get plain text. We're going to do METARs first. I'm going to go over TAFs in a second. What you can do here is you can come in here and you can type in your location. I'm going to put in Deer Valley Airport in Phoenix. It gives me the METAR. Here's what I would do if I were studying and trying to figure these things out. Arizona, Phoenix, this area, we always have clear skies, 10 statute miles, clear visibility. There's not much going on. If you live in an area where there's just not much going on, go look at other areas where things are happening. I'll show you how to do that in a second. Let's just decode this Deer Valley Airport. The airport identifier is KDVT. K means that we're in the contiguous United States, the lower 48. DVT is the airport identifier. This report was issued on the 13th day of the month at 1953 Zulu. We are 7 minus. So that is at 1253 is 126 right now. So that makes complete sense to me. Visibility is 10 statute miles. So if it's clear, it's called severe clear, right? Or clear air visibility unlimited. Generally, they're going to report 10 statute miles. They're not going to report 25 or 30 or whatever it is. 10 statute miles is that everything's good. Okay. So you'll generally see anything 10 or below. Clear means the sky's clear, no clouds in the sky. Temperature is 33 Celsius. Dew point is 2. So that is a pretty wide temperature dew point spread. So that means that is low humidity. Makes sense. I'm in the desert. And then altimeter setting is 2984, remarks AO2. That is the type of automated system that they have that can use human interaction. SLP is going to be your sea level pressure. So this is really just for aircraft that are measuring instead of inches of mercury, they're measuring things in millibars. Now, so what I would do is type in your local airport. If you don't know what your local airport is, let's go over that in a second. Type in the METAR, try to decode it. What I would do is sit down with a piece of paper and just write it through. That's what I would do. Then come over here, click plain text, and it's going to decode it for you. So you can check to see if you got it right. Phoenix, Deer Valley, blah, 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 10 statute miles. You got it. I got all the information there. So not much happening in Phoenix. So what I can do is I can go look at the NOAA weather reports, see if I can see any sort of radar of things that are happening. I can see this radar right here. I can see where something is happening. So I can go and look at that particular airport right now and be like, okay, there's stuff going on there. Let's go take a look at that METAR. So it looks to me like there might be some stuff happening in Corpus Christi, San Antonio, Houston. Beaumont might be a good one to look up. That looks like it's right on the border. So that must be Beaumont, Texas. I don't know the 3-letter code for Beaumont, Texas. So the website you can use to look up airport codes is called AirNav. This is a fantastic website that gives you all sorts of information about different airports. So you can come here, click on airports, and I can type in Beaumont, see what we find here. Beaumont, Texas, TS09. That's the identifiers, TS09. Might not have a METAR. It might be too small of an airport to have a METAR. Generally, right here. KBMT, Beaumont Municipal Airport. That's what we want. KBMT. Okay, so there must be multiple airports in that particular area. Then what you'll want is you want to find the one that's got like the 3-letter identifier like that. Those like TS09 and some of those other ones with numbers and stuff in them. Oftentimes those are private airports, small airports that just don't have any of these types of services. So you're going to want to look for that 3-letter code. So KBMT is going to be the 3-letter identifier. I'm going to come back over here to the 1-800-WX-BREATHE or flight service website. I'm going to type in KBMT here and I'm going to select METAR. And then what I'm going to do to really give myself the opportunity to practice and to drill and to just make sure I know how to read these, what I'm going to do is take this METAR right here. I'm going to take it and write it down in a notebook. And I'm going to write down exactly how it is. Okay. And I don't want you to type this. I don't want you to think this in your head. I want you to write this out on a piece of paper. There's research out there that shows that when you write things out, this is why it's always a good idea to print things out, take notes, write in books, that you will remember things. Okay. So if you just practice some of these METARs by writing them out, you can do this with TAFs too. And we talk about those later. Write these out and then decode it, write out the decoding of it as well. So this METAR right here, we got some stuff going on. We got some stuff going on in that area of Texas. It is now moderate VFR in Texas. So we've got something, either the clouds are low, the visibility might be low. So when we're looking at it, again, we've got our identifier KBMT. This is valid at 13 Zulu, this was published at 22:55 Zulu. The wind is 270 at 6 knots, 5 statute miles visibility. So that right there is what's making this moderate VFR, sometimes called marginal VFR. 3 to 5 statute miles is where you're going to get that marginal VFR. It's that section between VFR and IFR. We have thunder showers and rain in the area. Clouds are scattered at 4,600 feet, scattered 046. And then we have a ceiling of clouds that broken at 090, so it's broken at 9,000. And then we have another ceiling overcast at 11,000. Look at this. Temperature is 20. Dew point is 20. So that is probably another thing that is lowering our visibility. When the temperature and dew point come together, generally you get some sort of visible moisture, either in the form of fog or clouds, that kind of thing. Your altimeter setting here is 2984. Remarks, we've got an automated O2 system. It's the type of automated system that it is. We've got lightning in the distance. And then we've got some other information there about the temperature and dew point. So when we click on the plain text here, now after you have written out that METAR, you have written out the decoding of it, you can come here and use this plain text to make sure that you got it correct. Now, some of these things that you'll see in the remarks, like these things right here, generally you're probably not going to see that on the test. You're really going to see more things on just how to read the basics of the METAR over here. Okay. And so things like temperature, dew point, cloud levels, different cloud ceilings, wind direction, wind speed, how to identify what is TSR. If you see BR, what does that mean? If you say FU, what does that mean? They'll ask you those types of things. So that's what you're going to need to know for the Part 107 exam. So if you don't know your local airport where you live, you can just come up here. Again, you can just type in, I'm going to type in Shawano, Wisconsin, which is where I have family. Now, it would found Shawano Medical Center Airport. So remember I said the ones with the numbers are generally going to be like, they're going to be private airports. And so they might probably are not going to have METARs. So you're going to want to find the 3-letter identifier that's probably the closest to you. On this particular case, Shawano does have one. It's called EZS. So I could go back over to 1-800-WX-BRIEF, put in KEZS, they have an automated weather system there. You could also be like, all right, the city I live in or the airport that's closest to me doesn't have automated weather reporting or a METAR reporting system. Then what you're going to do is you're going to want to find that airport that's closest to you that does have it. Okay. And then you can use that to start practicing. Because, like I said, when I was going through my example, the one for Deer Valley, I was like, okay, yeah, that makes sense. This was 20 minutes ago that this was issued. That makes sense. The temperature dew point spread makes sense. It's the desert. It's dry here. It makes sense that the sky is clear. I can look outside right now and see that there's no clouds. It makes sense. You have the context there versus if you start looking up airports in other parts of the country that you might not physically be there, you don't know what's happening there. So that's how I suggest that you prepare for learning how to read METARs. Now let's learn how to read TAFs. So TAF is a terminal aerodrome forecast. So this is going to be a forecast for a particular airport and the area around that particular airport. So it's established for the airport in 5 statute mile radius around that particular airport. It is important to note that not every airport has a TAF. Not every airport that has a METAR reporting system has a TAF. A TAF report looks very similar. You can see the example right here in the Pilot's Handbook of Aeronautical Knowledge. We are in chapter 13. This is page 13-9. You have an example of a TAF right here. They read very similarly to a METAR. The difference is you get multiple lines for different time periods and different dates. The report will be for a 24 or 30-hour time frame. If it's 2:00 in the afternoon right now on a Monday, and it's a 30-hour forecast, I'll have a forecast up to 8 p.m. tomorrow night. But it's also important to note that forecasts get better the closer you get to that time. Okay, so these are simply forecasts. So a TAF is read very similarly to a METAR. So you've got the identifier. So right here, again, I really wish maybe I should do this, but I really wish that like 1 type of report, they should label this 1 ICAO station identifier right here. 2, they should really do that. So maybe I'll do that. Date and time of origin. So that's when this report was put out. This report was created on the 11th day of the month at 11:30 Zulu. All right. It is valid from the 11th day of the month at 12 Zulu to the 12th day of the month at 12 Zulu. So it is a 24-hour report. Okay. And what it's going to give you is different time segments now. So it gives you those valid period dates and times. It's going to give you forecast wind, forecast visibility, forecast significant weather, forecast sky conditions, things like this. So rather than it being a METAR where it's these are the conditions right now, the TAF is this is what the predicted conditions are going to be during this time frame. Okay. So the next line here is tempo. So from temporarily on the 11th day from 12 Zulu to the 11th day at 14 Zulu. So between 12 and 14 Zulu, temporarily the visibility will be 5 statute miles because of mist. BR is mist, right? Then from 1500 Zulu, we're forecasting the winds to be 160, 15 gusting to 25 knots. So wind, again, you can remember you get a 3 number direction, your wind speed. If you see the G, that's a gust, KT is knots. Now, this is one thing that is a little bit different from a METAR. So METARs are going to report statute miles visibility up to about 10 miles. Generally speaking, it's going to report up to 10 miles. In a TAF, visibility is unlimited. They're going to report P6 miles, which means greater than 6 miles visibility. Okay. So if you see that P6SM, greater than 6 miles visibility, it probably stands for something French. Now you have your skies are going to be scattered at 4,000 feet, 040, and then broken at 250. So the skies are going to be broken at 25,000 feet. The clouds are going to be broken. So that's where the ceiling is 25,000 feet, way higher than we need to think about it as a remote pilot. Then, so this is from 1500 Zulu. Now we're going to go on the 12th day at 0 Zulu. So 9 hours later, we're going to have wind at 140 at 12 knots, visibility bit greater than 6 statute miles. Clouds are going to be broken at 8,000, overcast at 15,000. And then there's a 30% chance probability that between the 00 on the 12th day and 04 on the 12th day, so that 4-hour time window, there's a 30% chance that the visibility will drop down to 3 statute miles. We'll have thunder showers and rain. We'll have broken clouds at 3,000 feet with cumulonimbus clouds, which is indicating thunderstorms. Okay. Then on the 12th day at 400 Zulu. Okay. So again, we're laying out time periods here. Wind is going to be 140 at 8 knots. So our wind is coming down. Visibility goes back up to greater than 6 miles. Sky's starting to clear up here. Scattered 4,000 feet, overcast 8,000 feet. Then temporarily between on the 12th day from 4 Zulu and the 12th day at 8 Zulu, our visibility will drop back down to 3 statute miles visibility, thunder showers and rain, overcast at 3,000 and cumulonimbus. So this forecast over the next 24 hours is really showing we got weather moving in. It's going to clear up and then weather is going to be coming in and out. All right. So it's the same decoding as a METAR. It's just put into these different time periods. So it's really understanding how to read those time periods. And then if you've got the METARs down, you can read the TAFs. That's what you need to know about the TAFs. Let's practice how to read TAFs. We're going to do the same thing that we did for METARs. Okay. I'm going to go back to Deer Valley here. And I don't want the METAR now. I want the TAF. Oh, we got the plain text down. I don't want the plain text. Okay. So same thing. You're going to do the same thing here. I would take this, write this TAF down on a sheet of paper, exactly how it's written. Line 1, line 2, line 3. All right. And then you're going to write out the decoding. Then you come over here to the plain text and you decode it. All right. So we have the TAF, the station identifier issued the 13th day of the month, 1720 Zulu. It's valid on the 13th day of the month from 18 Zulu to the 14th day of the month at 18 Zulu. We've got wind, we've got visibility, we've got cloud conditions, sky clear. Okay. So these are issued for a 24 to 30-hour period. They do get updated. So just because you read a TAF right now doesn't mean it's going to be the same TAF 6 hours from now. So let's say you look at a TAF because you're going to fly. It's the morning and you're going to fly this evening and you look at that TAF. I would watch that throughout the day, especially if There's a possibility of rain, clouds, low visibility, low clouds, things like that. They can change. TAFs are a forecast. METARs are the current conditions at an airport issued hourly. Okay. So that is how I would suggest that you study for Part 107 exam to learn how to read METARs and TAFs. When you get your certificate and you're out doing pre-flight planning, come here, certainly read the coded TAFs, the coded METARs, but then don't feel like you can't use the plain text. It's there. It's there for a reason. Okay. So you can certainly use that. You might be given some weird, obscure code. And again, in your Part 107 course, I've got a list of some of the different codes that you might see on the Part 107 exam. They'll say, okay, what does this mean? Okay. And again, if you get something like missed and you can't remember what it is, then you might have, maybe you have different options. You've got mist, you've got rain, you've got snow, and you've got thunderstorms, right? And you're like, oh, I can't remember what BR is. I do know that rain is this, and I do know that snow is this. So by process of elimination, you can figure out it's mist. Okay. In the real world, you'll be able to look this kind of stuff up. All right. So that is my quick and dirty lesson on how I think you can study for the METARs and TAFs portion of your Part 107 exam.